Hello friends, welcome to DCB Online, and in this video we are going to study how to construct the stiffness matrix for frame element, and the next video tutorial would be solving an indeterminate beam using stiffness matrix concept. So let's get started with this. Here as you can see we have got an element A and B, but before that we'll have to see what are positive forces and moments. So step 1 is to draw positive forces and moments. Positive forces and moments are those forces which act along the Cartesian coordinate system. As you can see here, this is the Cartesian coordinate system with x, y, and z axis, and the forces acting along these axes are termed as positive forces. So a force along y, a force along x, a force along z, and double arrows meaning moments. The double arrows meaning we get the moment by right hand thumb rule when the thumb is in the direction of the double arrows and the curl of the finger denotes the moments, the direction of the moment. So an anti-clockwise movement along the y-axis, similarly an anti-clockwise movement along the x-axis and an anti-clockwise movement along the z-axis gives you the positive moments, and these are the positive forces. So these forces and moments we have to draw first. That is our first step. So at both the joints, that is A and B, we draw the positive forces, that is this acting in the x direction, again you're acting in the x direction, this force acting in the y direction, and moment along the z direction. Okay, anti-clockwise movement. Step 1 is done. Step 2 is to number the forces, moments, and points. Now this step is very important because your whole stiffness matrix will depend upon how you number the forces and the elements. So we'll start from horizontal force, giving horizontal force, then vertical force, and then the moment x, y, and z. Hope you got it. X, y, and z. So 1, 2, 3, 4, 5, 6. This is how you number the forces, and point 1 and point 2, that is A and B. Uh, you should not make any mistakes while numbering the forces and the elements. Now we'll check what is displacement due to force 1. What is force 1? Force 1 is an actual force, and we'll check what displacement the actual force does. So unit displacement at point 1 due to force 1, and it displaces as it is very obvious, it will displace in the actual direction, and the force that requires to cause a unit displacement in the actual direction, it is given as AE by L. If you have not seen my previous video of stiffness matrix concept, the stiffness matrix basics, please check it out. In that video I have explained how these values have come, okay, how the force and the reaction values come. So please check that video out. The link will be given in the description. And the reaction for this will be AE by L in the opposite direction here. And these will be obviously zero because there is no moment, there is no bending or twisting of the beam, hence no moments, no vertical forces, as the only force that is acting is a horizontal force, hence it gets only a horizontal reaction. Now comes a very important part, that is to write the elements of the stiffness matrix, that is S11. What is S11? S11 is force or reaction number 1 due to force 1. So S11 is force or reaction at number 1, force or reaction at number 1. This is number 1, right? So force is AE by L due to force 1. So force and force both coincide with each other. Force at number 1 due to force 1, both are the same, that is AE by L. Hence S11 is AE by L. S21 is 0. What is S21? Force or reaction number 2 due to force 1. So due to this force, there is no force or reaction at number 2. As you can see, this is number 2, and there is no reaction formed due to my force 1. Hence S21 is 0. S31 is again 0 because there is no moment formed due to application of force 1. So S31 is force or reaction number 3 due to force 1. Hence S31 is also 0. Now S41 is negative AE by L. Why it is minus AE by L? It is first of all force or reaction number 4 due to force 1. As you can see, these are our positive directions, right? And the positive direction at 4 is going rightwards, but the reaction formed at 4, number 4, is in the left direction. Hence we have to write it as minus AE by L, as it is not in conformation with the positive forces. It is opposite to the positive force, and anything that is opposite to positive is obviously negative. Hence the reaction at number 4 is minus AE by L. S41 is minus AE by L. S51 is 0, that is force or reaction at 5 due to number 1, force number 1 is 0, and S61 is also 0, force or reaction number 6 due to force 1. So I hope you got this, how to plot the elements of the stiffness matrix. This forms the first column of my stiffness element matrix. S11, 21, 31, 41, 51, 61. My stiffness matrix is going to be a 6 cross 6 matrix. Now let us check the displacement due to force 2. This is the force 2, and let us see how my beam gets displaced when we give a unit displacement. So unit displacement at point 1, that is this point was uh, numbered as 1. Unit displacement at point 1 due to force 2. So this is our force 2, and it is going to displace my beam like this, giving a unit displacement, and my beam will get displaced like this. The force that causes this unit displacement is given as 12 EI by L cube, and the moments formed are 6 EI by L square, again here 6 EI by L square, here 12 EI by L cube. Now all these things are explained in my previous video, stiffness basics, and I recommend you to please check that video, where you will know how these directions of the moments and how the directions of the reactions are formed, and it will be much easier for you to grasp this video tutorial. So these are the reactions and the forces due to this force. These are the reactions in blue, and the force is in red. Now let us plot our stiffness elements, and again the actual forces are 0 because there is nothing here, right? There is only a vertical force, no horizontal force, hence horizontal reactions are obviously 0. Let us plot the stiffness elements. S12 is 0 because due to force 2, there is no force or reaction at number 1. Number 1 is 0, hence S12 is 0. S22, that is force or reaction number 2 due to force 2. Force or reaction number 2 is the force itself, that is 12 EI by L cube, hence it is S22 is 12 EI by L cube. S23 is, S32 is force or reaction number 3 due to force 2. Now force or reaction number 3 is 6 EI by L square, and our positive moment is anti-clockwise. 6 EI by L square is also anti-clockwise, hence it is plus 6 EI by L square here. S32 is plus 6 EI by L square. S42 is 0 because there is no actual force at number 4. Actual force is 0. S52 is minus 12 EI by L cube, that is force or reaction number 5 due to force 2. Why it is negative? Because our positive force at 5 should be an upward force, but as you can see, upward force or reaction, whatever, but as you can see here, my reaction is downwards, which is not conforming with my positive forces, hence it is negative 12 EI by L cube. S62 is 6 EI by L square, and it is again anti-clockwise, which conforms with my positive directions, hence it is plus 6 EI by L square. This forms the second column of my stiffness element matrix. S12, 22, 32, 42, 52, 62. Now we'll check what happens when we give displacement due to force 3. So unit displacement at point 1 due to force 3. Force 3 is a moment, and it is in anti-clockwise direction. What will happen if we give an anti-clockwise unit rotation here? So this is rotated, and theta is equal to 1, that is unit rotation, and the reactions formed due to this are, first of all, the moment that causes this unit rotation is 4 EI by L, and the reactions are 2 EI by L anti-clockwise, 6 EI by L square downwards here, and 6 EI by L square upwards. Again, everything of this is explained in my previous video. And the axial forces are zero because there is no horizontal force to cause the axial reaction, hence they are zero. Now let us check stiffness elements. S13 is force or reaction number 1 due to force 3. Now due to rotation of this moment, there is no force or reaction at 1, hence it is 0. S23 is 6 EI by L square. S23 is 6 EI by L square, which is upwards, which conforms with my positive directions, hence it is 6 EI by L square. S33 is 4 EI by L, which is the moment itself which is causing the rotation, 4 EI by L. S43 is 0 because there is no reaction, there is no actual reaction here at number 4. S53 is minus 6 EI by L square. It is negative because the force, positive force 5 is upwards, but the reaction that we are getting here is downwards, hence it is not conforming. Therefore, it is negative 6 EI by L square. Just a minute. Okay. And S63, that is force or reaction number 6 due to force 3, is 2 EI by L anticlockwise, which is conforming with our positive moment direction, hence it is plus 2 EI by L. This forms the third column of my stiffness element matrix, S13, 23, 33, 43, 53, 63. And now we'll check displacement due to force 4. And as you can see, force 4 is acting at point 2, hence it is unit displacement at point 2 due to force 4. Now as you can see, the force 4 is an actual force and it is going in the right direction, hence this force 4 will act here and it is going to elongate my beam. This is the unit displacement that this force has caused, and the magnitude of this force causing unit displacement is again AE by L. All other reactions are 0 except the actual reaction at point A, that is point 1. It is AE by L in the opposite direction to this force. Now S14 is minus AE by L. As you can see, it is force or reaction number 1 due to force 4. Now due to force 4, the reaction at 1 is formed and it is AE by L but in the opposite direction to this force, positive force, right? Hence it is minus AE by L. S24 is force or reaction number 2 due to force 4, which is 0. It is self-explanatory now, and you must be knowing why it is 0 because all other reactions are 0. S34 is also 0. S44 is AE by L, which is the force itself. S54 is 0. S64 is 0. This forms the fourth column of my stiffness element matrix. Displacement due to force 5. Unit displacement at point 2, that is this point, due to force 5. This is my force 5, and let us see how it displaces my beam. My beam gets displaced like this, a unit displacement, and the force causing this unit displacement is given as 12 EI by L cube. This is similar to the forces that we have done here. Now everything is similar to the forces here, except the direction of the reactions will now change. Okay, 6 EI by L square formed here, which is clockwise. 6 EI by L square formed here again clockwise, and 12 EI by L cube downwards, and no actual reactions. Now S15 is 0 since there is no actual reaction at point 1 due to displacement by force 5. S25 is minus 12 EI by L cube because it is acting in the downward direction and my positive force is upwards, hence it is minus 12 EI by L cube. S35 is again minus 6 EI by L square because it is clockwise and my positive moment is anti-clockwise. S45 is 0, that is force or reaction number 4 due to force 5. S55 is plus 12 EI by L cube, which is the force itself, and S65 is minus 6 EI by L square, which is clockwise and it does not conform with our positive moment. This forms the fifth column of my stiffness element matrix. Let us check displacement due to force 6. Unit displacement at point 2 due to force 6. Again, my force 6 is the moment, anti-clockwise moment, and it is going to rotate my beam like this. unit rotation formed here, that is theta b equal to 1, and the reactions formed due to this are 2 ei by L anticlockwise, 6 ei by L square downwards here, and 6 ei by L square upwards, and no actual forces. So S16 is 0 because no actual force here. S26, that is upward force, is plus 6 ei by L square. S36 is 2 ei by L, which is again positive because it is anticlockwise. S46 is 0. Okay. S56 is minus 6 ei by L square. So I hope by now you must be getting how to write the direction, how to write the sign conventions. That is, whether it is minus 6 ei by L square or plus 6 ei by L square. We have to always refer these reactions with our positive force. Okay. And S66 is 4 ei by L, which is the force or moment itself, and it is always positive. And this forms the last, that is sixth column of my stiffness element matrix. Now this is how my stiffness matrix looks: S11, 12, 13, 14, 15, 16 till S61, 62, 63, 64, 65, 66. So we have here 36 elements, and we have to substitute all the elements here. Now once you substitute all these elements right from S11 to S66, you will get this type of stiffness matrix. Now that is one very important thing to notice in the stiffness matrix is that you can divide this into four quadrants, that is for 1 2 3 4. Okay, 1 2 3 4, and in all these four quadrants, if you see, then all the elements are similar except these last one. Okay, and the first quadrant and the fourth quadrant are exactly same except for the signs here and there, and the second quadrant and the third quadrant is exactly same except for the signs here and there. I'll tell you about the signs, how to write them, but for now you just take a note of this, that all the elements in the second and the third are same, all the elements in the first and the fourth are same. Now what you have to do is, you basically only have to remember these 9 elements, because what happens is that while solving an indeterminate beam, you have to write this whole stiffness matrix, and at that point of time you cannot derive this stiffness matrix because it will take a lot of time and you won't be having time in your exams. So you must be knowing this stiffness matrix by heart. How to remember the stiffness matrix, I'll tell you. You just have to remember these 9 elements and then copy these 9 elements in the third quadrant except for the last one. Last one you replace it by 2 ei by L. So basically you have to first fill these three columns. Okay, these three columns have to be filled by writing these 9 elements, then copying the same 9 elements down and in the third quadrant, and just replacing 4 ei by L by 2 ei by L. And now what you have to do is, the fourth row and the fifth row is negative of second and third, so you just have to change the signs of fourth row and fifth row. That is, if this was plus ae by L, this will be minus ae by L. If this was plus 2 ei by L cube, this is minus 2 ei by L cube, plus 6 ei by L square, minus 6 ei by L square. Okay, which is very simple. First you write these 9, then write these 9, then change the sign of fourth and fifth row. Okay, and now you have three columns with you. The fourth column is negative of first column, that is, if here it is plus ae by L, here it is minus ae by L. If here it is minus ae by L, here it is plus ae by L. The fifth column is negative of second column, that is, if here it is plus, here it is minus, plus minus minus plus plus minus. And the sixth column is identical to the third column, except you have to change the 4 ei by L to 2 ei by L and 2 ei by L to 4 ei by L. That is, interchange these two, the positions of these two elements in the sixth column. So I hope you got how to remember this stiffness matrix. Again, I'll repeat if you want. First you have to remember these 9 elements. You have to copy these 9 elements in the third quadrant, replacing the last element by 2 ei by L. Then change the sign of fourth row and fifth row, and now fourth column is negative of first column, fifth column is negative of second column, sixth column is same as third column, and you have to interchange the third and sixth element. That is, these two elements need to be interchanged in the sixth column, and then you will be able to remember this stiffness matrix very easily. So I hope this lecture was fruitful to you, and please like, share, and subscribe. Click the bell notification icon for more such videos. It will be really appreciated. Thank you.